All right, so consider this function, evaluate f of g. So if we put f of g in, you can see we get g minus g squared on g. Let's put g minus 2g log g on g. So we've got log 1. All right, so we know log 1 is 0, so g minus g is also 0, so you can see f of g is 0. Now f dash of g, this is, f dash of x. So we're differentiating x, so this has got x to the negative 1, so if the negative 1 comes down, it's plus. We've still got g squared, but now it's x to the negative 2, and it's a log, so we've got 2g on x. So if we look at that, we've got 1 minus, I'm going to put just swap the terms around here. And this is g on x squared, so you can see it's a perfect square. So if f dash of x is always positive, that means if we're looking at gradient, that's always positive. And if we're starting at 0 and it's always positive, then we know f of x is always positive. All right. So if a body is moving vertically through a resisting medium with resistance proportional to its speed, so there's your negative kV. So what we've got, and we usually say x double dot, but since the motion is going in the vertical direction, we can always change it, as they have here, to y double dot. All right, so we've got gravity going against motion. We've also got the resistance. Okay. So let's just show that double dash we're given. So that's what we're given, but it just comes from what they talked about there. All right, so if we're looking for, let me just move this over. So here we go. We're finding v as a function of t. I'll just put that over there. So if I go back to that equation, I've got y double dot being minus g minus kv. We're looking for a velocity time, velocity as a function of time, so we would use dv dt to represent our acceleration. And then, so we need to turn everything upside down, and t is going between 0 and t. And if I turn this upside down, I've got a g plus kv on the bottom. I've got dv. I need so I've got a minus out the front. All right, and then you can see to balance it, or to make a log, I need a k here, so therefore I'm going to put a 1 on k out the front. All right, also, where is it going from? It's going from an initial velocity v0 up to a velocity v. So let's make it, so it's clearly going to be a log of g plus kv, and I'm going to swap the limits around, so that takes care of the minus that was in front. I'm also going to times the k over this side, so I've got kt, and you can see I've got log of, so if I sub in the first one, I get kv0. If I sub in the next one, I've got g plus kv. All right, so if I exponentialize both sides, so I've got e to the kt being the fraction, and then remember I want v as the subject, so I'm going to times that over, and at the same time I'm going to divide, so I've still got g plus kv0. I'm kind of skipping steps here. I'm going to put the e to the kt on the other side, so it actually becomes e to the minus kt because I'm dividing by it. And then looking over here, I'm going to minus g and divide everything by k. And that will give me just the v by itself. All right. So then if I'm looking for, so find v as a function of t and hence show that. So now I'm looking for the actual, the y value. So I'll make v dy dt. You can see there's t's in there and the displacement. So if we make velocity dy dt and solve for, So that equals that expression. So if I integrate between 0 and y, some displacement y, I've got, so I'm integrating with respect to t between some 0 and t, and I've got, alright, so I'm going to put this here first, so g plus k v naught e to the minus kt minus g to t. Okay, just go up here. So we've got 1 on k. Integrating the first term here, I'm going to have g plus kv0. So I've got still e to the minus kt, but I'm dividing by minus k. And for the other term, integrating, I've got minus gt. Remember, I'm going between 0 and t. I might times the other side by k, so I've got k y. And then I've got, so when I sub t in, I've got g plus k v0 on minus k e to the, minus kt minus gt. Now sub 0 in. So clearly this term is going to be 0, but the first term when I sub, so there's a minus k on the bottom, so I'm going to make it plus. I'm going to get the g plus kv0 on k. Yeah, so I'm getting all that. So what I can do is put in a k here. So that's over a k as well. And maybe I'll put the minus up here. So that's a plus. So then I can multiply by another k. So I do get the k squared y, which is what we were looking for. I'll put the last term first, so g plus kv0 first. Then I'll put the middle term, so minus gtk. And then the first term, which was g plus kv0 e to the minus kt. Alright, so if we factorize by this, so the first term is 1 and the last term is minus e to the minus kt, and I've still got that minus gtk there. I think that's what we were looking for. Let's check. Alright, so that gives you that equation in part 1. So part 2, we have to find t, the time taken to reach the maximum height. So if we go from our velocity equation, so if I go from this equation here, when we reach our maximum height, we know the velocity is 0. So that gives us our t, our h max, or the time of our h max. Alright, so when we do that, if velocity equals 0, then, you know, when I times k over, I'm timesing k by 0, so that's 0 as well. So really, just this top of the fraction here has to equal 0. So that means that the g has to equal e to the minus k maximum time, the time of maximum height, g plus kv0. So all I need to do is really rearrange this. Alright, so divide. So I've got e to the minus kt, and then log both sides. kv0 is minus kt, and then make t the subject, so I'm dividing by minus 1 on k, or I can divide by k and then swap the log around, so then I don't have to worry about that minus. So g plus kv0 on g. Alright, so that's our time it takes to reach the maximum height. If I want to show this equation here, it says when time is 2t. So if I take my time here and double it, clearly we're just going to get 2 on k log g plus kv0 on g. So if I then sub that into this equation that we got, where is it? K squared y equation. Yeah, so I'm subbing that into this equation here. So I will get, oopsie daisies. There we go, like that. So here we've still got k squared y, and we're subbing in, so we've still got that, we've still got this. I should do this separately, sorry. So e to the minus kt, where t is now 2 on k log g plus k v0 on g. So you can see here these k's will cancel, and I've got, if I put that 2 up to the power, so I don't have that using log law, so that 2's not there, and actually make it a minus 2, and then that's not there either. So then I've got exponential log, so they cancel, so I've just got g plus kv0 on g squared for that part. So here I've got 1 minus g on, so 1 minus, did I make that a minus 2? I think that should be to the power of minus 2. Alright, so if I make it plus 2, I can just swap it around. Better do that as well. So here I've got minus g on g plus k v0 squared, and then minus a gk times that time would be minus 2g log g plus k v0 on g, using this for my time. Okay, so let's have a look at that. So we've got g plus kv0 times 1, and then minus, alright, so g plus kv0 times that, remember it's squared, so I still have the g squared, but I'll only have one of the g plus kv0s here, minus 2g log g plus kv0 on g. Alright, so I hope that helps. Just lots of algebra, hopefully helpful.